All right, so here's a problem that involves rational expressions, that sort of thing. And so you may see a problem similar to this if you're studying fractions involving x's and y's and that sort of stuff. Mike can drive 2 times as fast as Brian can ride his bicycle. If it takes Brian 3 hours longer than Mike to travel 84 miles, how fast can Brian ride his bicycle? All right, so that's not too bad. So now what we need to do is we need to figure out how we can get fast time. Let's see, where am I here? 3 hours. So fast is a rate. Hours is a time. And 84 miles is a distance. And so now we need to figure out, well, how can we relate those 3 things together? And we can do so with these 3 different formulas. I tend to remember that rate is actually equal to distance over time. And I do so because I look at my speedometer, and my speedometer tells me how fast I'm going. And it measures in miles per hour. Or, you know, if you're reading this and you're in any other part of the world in the United States, it's kilometers per hour. But point being, it's a distance divided by a time. After that, it's just a little bit of algebra. And so if we simply multiply both sides by t, then we get d is equal to r times t, which is distance equals rate times time. That's the one most people tend to be most familiar with. This one, however, because it compares times, we need it in terms of times. And so if I just divide, if I divide that second equation by r, then I get t is equal to d over r. So now we just need to know certain things. And so we're going to have, we'll have Mike up top, we'll have Brian down below. We're going to have our distance here, we're going to have our rates here, and then this is going to be our time, which is distance divided by rate. All right. So for Mike can travel 2 times, well, first of all, they're both traveling 84 miles, so we can just plug that in here. Then my rate, okay, so Mike can travel 2 times as fast as Brian can ride his bicycle. At this point, we need to define our variable. The easiest way to do this that I've found is to go to the question, think about what it's asking, how fast can Brian ride his bicycle? This is your x. So Brian's rate is x. Mike can drive 2 times faster, so that's 2x. Finally, we have, if we put these 2 together, I'll do it in dark blue, or kind of a darkish blue here, we have our distance over our rate and our distance over our rate. Now, it takes the second sentence in order to put these 2 things together. If it takes Brian 3 hours longer than Mike, remember these are hours. If it takes Brian 3 hours longer than Mike to travel 84 miles, well, now ask yourself a question. If I have, for instance, if I have $10 and my wife has 3 more than me, then I add that to me. All right, so I always add it to the one that's the shorter of the 2. In that case, then I add it to Mike. So Brian's time is 84 over x is equal to 3 more than Mike's. And that's one way to set it up. Another way you may see it set up is, or another way you can think about it is the difference between them. If one goes longer than the other, then the difference between them is 3 hours. That's another way to think about it. Now, which one of these should you put first? In this problem, it's probably not going to mean a whole lot of difference. You may get a positive and a negative answer here, but the idea here is once you choose, think of the one that's a little bit more right. You're going to get a feeling for it, and then just if it happens to be negative, just apply it. Just take away the negative. If you think of it in terms of differences like this, then but if you're not really careful, then probably about 75% of the time you get it right. 25% of the time you might reverse those 2 things, which is going to give you a negative answer. Okay, I'm going to go ahead and tackle this first one here. They both work the same, but I'm going to, because this is the one I derived, and I think it's the easier one to work with, I'm going to go ahead and tackle this one. So to solve these things, we simply just multiply both sides by the least common denominator. So we're going to take x and 2x, share 2x as a least common denominator. I'm going to go ahead and multiply this through. When I do that, if I just kind of spell it out here, I'm just multiplying into the denominators. It's all, into the numerators. So 2x times 84 over 2x plus 3 times 2x. And then if I simplify this down a little bit, then I get my x's cancel here. I'm left with 168. My 2x cancels with 2x, and I'm left with 84. And then my 3 times 2x is just plus 6x. And then if I solve this, then I subtract 84 from both sides. It gives me 84 is equal to 6x, the other x. And then I divide by 6, and that's going to give me 1014, it looks like. And so I have 14 is equal to x. Because we only came up with one answer here, if you were to solve the other one and you happen to reverse those, you'd have gotten a negative 14, which wouldn't have made a whole lot of sense. And so it should shove you back into the problem naturally and say, well, what did I do wrong? But now, 14 miles an hour is who? Well, if we look back up here to what we called x, it's how fast can Brian ride his bicycle, 14 miles an hour. That's a reasonable speed, and so we'll use that information to assume that we're correct. So Brian can ride his bike at 14 miles an hour. And that's it. That's the problem. All word problems work like this. Start off, what are you looking for? The next thing is, what kind of measurements do you have? And if there's a formula that goes with those measurements, great. If there's not, you got to come up with one. And that's it. After that, it's just plug and chug. All right. I hope you enjoyed it.